Hello everybody, thank you for watching. This is our 2.7 nuclear stability video. The objectives for this video is to just talk about what is nuclear stability and then how can you tell if an atom will be stable or unstable just by looking at the protons and the neutrons in the nucleus. So let's just generally talk about nuclear stability. So we want to figure out what subatomic particles even are involved when talking about nuclear stability. And if you take a look at this image right here, we know that we have protons and our neutrons inside of a nucleus. So that kind of makes sense because that's what's going to determine if a nucleus is going to be stable or not. So the key point here is an atom's stability is determined by the number of protons and neutrons in the nucleus. So let's talk about stable versus unstable. So we have three examples right over here. This is an atom of carbon-12 where you have 6 protons and 6 neutrons. And then you have this carbon-13, which we have 6 protons and 7 neutrons. And then lastly, we have carbon-14, where we have 6 protons and 8 neutrons. The first carbon is just, we're going to call that stable. So nothing really happens to stable nuclei. They just kind of exist. They don't do anything, nothing changes, they're just there. The problem is what happens when things become unstable right here. So this example of carbon is a less stable carbon, and then the carbon-14 is a very unstable nuclei. So what does that mean to be unstable? Brings us to this key point over here. Unstable nuclei, they're considered radioactive. So what that means is the nucleus will start to decay, which also means break apart, and it starts to shoot out these different protons and neutrons. So this is what happens to unstable nuclei. So how do we even figure out if a nucleus is going to be stable or not stable? So it really comes down to the number of protons and neutrons and that ratio inside of the nucleus. So I want you to look at this key point over here. So for every small nuclei, about 1 proton requires about 1 neutron in order to have a stable nucleus. So if you remember going back to our example of carbon-12, where we had 6 protons and 6 neutrons, we have a stable nucleus because the ratio between our protons and our neutrons is ultimately a 1-to-1 ratio. Our key point on the right side over here, what happens when we have larger nuclei now where we have multiple protons and multiple neutrons? That ratio changes just a little bit because now we have higher numbers of our atomic numbers. So for larger nuclei, we have a ratio now of 1.5 to 1 ratio. So this is an example of lead. In this lead example, we have 82 protons and 124 neutrons. And you can see that the ratio is not really 1-to-1 now. It's kind of just 1.5-ish around there. So just 2 key points to keep in mind when you're determining nuclear stability. So let's talk about our different nuclei and then how can we figure out for any atom if it's going to be stable or not stable. So we have an example right here, which is we're talking about mercury, right, Hg. This graph right over here, we call this a graph of where we have protons on the x-axis and our neutrons on the y-axis. So you can see as our protons to neutron ratio is 1-to-1, it's pretty much touching this red line right over here because it's a 1-to-1 ratio. When you start getting bigger, when you have more protons and more neutrons, you can see that the band kind of shifts and now it's touching this 1.5-to-1 ratio. So in between this area right here, we call this the band of stability. So if you want to ever figure out if your atom is going to be stable or not, you need to figure out the number of protons and the number of neutrons and look at that ratio. So for mercury, what I want you to do is pause the video and take a look at how many protons this mercury atom has and how many neutrons it has, and then try to figure out by looking at the band of stability if it's going to be stable or not. So now you should have your number of protons. So if you take a look at the periodic table, Mercury has 80 protons. That's the atomic number. And it has 90 neutrons, which is given to you in the problem. So if you take a look at your x-axis and go all the way up to 80 and make a pot right here, and our number of neutrons is 90. So we're right about here. You can see that we're nowhere near this band of stability. So is this atom going to be stable or not stable? It's going to be very unstable. In order for it to be stable, it has to be inside of this band of stability, not the red lines, this black dotted line right over here. So if we wanted Mercury to be stable, you can see that if it has an atomic number of 80, it has to be somewhere around this range where it's like 120 neutrons for every 80 protons that it has. So this is just a quick recap of everything that we talked about in this video. At the end of this video, I hope you understand how to determine if a nuclei is going to be stable or not stable. Thank you for watching.